Hello, Isabella. We missed you here in class. We're going to begin on page 2, and the title of this lesson is Introduction to Algebra. I'm not going to make you take notes today because I want you to listen closely and learn from this and learn how to use our textbook. So everybody look on page 2, Introduction to Algebra. Okay, so as the textbook says, you've spent most of your past time mastering basic math principles, some pre-algebra to get you prepared for this class. But there are several key differences between arithmetic and algebra, so look at that with me on page 2. Number 1, arithmetic, which is math, of course, describes a specific situation. Algebra describes a general situation. Arithmetic performs mathematical operations on known numbers. Algebra performs mathematical operations on letters that stand for what? Those letters stand for what? An unknown value. In other words, that's what we're trying to find out, is what those letters stand for. Arithmetic expresses multiplication using the X symbol. You know that multiplication can be written with an X, a dot. How else? You can have 2 times 2, which is 4. 2 dot 2, which is, yes.
Pardon the interruption. I just wanted to let you know, I got a text that Noah will be having surgery in the morning to set both of his arms, Noah Walker.
Okay.
So I just thought I'd let you know, maybe you guys can say a prayer for him.
Okay, we'll be happy to. Thank you for letting us know.
All right, thank you.
All right. Okay, so now, also number 3, we talked about the different ways that you can express multiplication. 2 times 2, 2 dot 2, 2 times 2 in parentheses. You can also see them over here on the wall. 2, what do you all call that? A little number sign. Asterisk times 2 equals 4. Number 4, everybody look at number 4. Arithmetic expresses division using the symbol, the division symbol. Algebra uses a fraction bar, like 3 over 5. That's a fraction bar. That's also expressing division. Now, what is an algebraic expression? Everybody look at that with me on page 2. It's a collection of numbers and letters when they are combined together using arithmetic. You know, at the bottom of this textbook, it says that X is rarely used. I don't believe that, because X is used a lot in algebra, in my opinion. But they say, if you read it there, it says X can be confused with the letter X. It is rarely used in algebra. Well, then when you flip through your book, notice how many times X is used in equations. A lot. So I don't necessarily firmly believe in that statement. All right? So now, let's talk about... Let's move on to page 3. We talked about the ways that you can multiply. Let's talk about an expression. Does anybody know what is versus an equation, rather?
Okay, algebraic expression, just read it.
They're algebraic expression.
Is a collection of numbers and letters combined.
Okay. So this is an expression. 3x plus 2. Okay? Now, let's actually break it down and talk about what each of part of this expression is. This 3 is a what? Is referred to as what? The book calls it a numeric coefficient because it's a number, but you'll hear me commonly refer to it as just the coefficient. Okay? Of course, what is the x? It's your variable or your unknown, right? We know that's your sign. And this is what? It's not a coefficient. It's only a coefficient if it's in front of a variable. It's just a numerical number, right? Now, if you have a variable, let's just say we have x plus 2. If you look on page 3, it tells us here in the very top, but closer to the bottom of the first paragraph, if a variable is alone, there is an understood what coefficient? Understood number in front of it. We already know there's really an understood what there? 1. In other words, 1x is the same thing as x. Okay? That's always understood, and you'll understand later why I'm pointing that out, and that's important. Okay? Now, algebraic expressions can be broken down into quantities separated by addition or subtraction, and each of those expressions down are called terms. This is important. So if we have 5y plus 4z minus 6, we have how many terms here? 3. 3. This is a term, this is a term, and this is a term. Does everybody understand that? Terms are separated by addition, subtraction, okay? All right, so what is a constant term? Look in your book there. Someone raise your hand and tell me what a constant term is. When a numerical coefficient is alone, not multiplied by a variable, in other words, this 6 here is a constant term. You might want to underline that in your book. I like you guys are not talking. This is great. Thank you, Julia and Emily, for bringing quietness in the classroom. I'm sure that's what it is. Oh, and Talon. Yeah, it's great. Because usually they talk so much that I want to pull my hair out. Or jump in a lake.
Yeah, I was say or jump in a lake.
Or quit.
Or quit. Tried that too. Yeah, buddy. But I love them. Now, also know that an expression can be expressed like this. That's a z. This can also be referred to as an expression. Because algebra can be show division through a fraction. Okay? I know some of this may be boring to you, but it gets harder and funner. So, trust me. All right, so let's look on page 3 at 1.1a. And let's look at a. Okay, so you have x plus 2xy minus 5y over 4. I think they already tell you the answer, but we're going to talk about it anyway. So they want to know how many terms there are in this expression.
4.
There are 4 terms. Did they tell you the answer in your book?
Yeah.
Because they do in mine too. How about b? How many terms are in b? B is just one term. And it's 3x. See how many times they use x? Over 5. That only has one term. Okay, how about C?
2.
It has 2 terms. How many addition or subtraction signs do you have?
2.
You have 2, but you have 1 right in the middle, and that's actually separating the 2. How about D? 3. That's right, there's 3. I just want to go through these basics real good with us. All right, so if an expression is written with an exponent, okay? So if you have 4x squared plus 12x plus 9, the first term shows x is raised to what power?
The second
Second.
one.
To the second power. So that's an exponent, and that exponent indicates what?
The number of times x. Number of times x is raised.
Okay. So it's actually going to be multiplied by itself, right? The x.
Right.
So let's
X
say the
times
value.
x.
Let's say that value of x is 2.
2 times 2.
Then it's going to be 2 squared, which is 2 times 2, which equals 2, which equals 4. And that's actually going to be 16 when you can solve it through substitution. But anyway, make sure you understand that. So, if you have 4x squared, this is your what? We just talked about that. What's the number in front of your variable? Coefficient. You will need to know these. These type of things will you'll be quizzed on at some point in time. That is your coefficient. Okay, what is x?
Exponent. Or, oh, yeah,
It's variable, but in this case it's a variable, but it's really your base. It's a variable. I call them variable base because it's the base of an exponent, because this is your exponent. But if I ask you that and you put variable or base, I wouldn't mark it wrong because really it is a variable and a base. So we know that x with a 5 exponent is really read x to the what power? Fifth power. What about x to the third? Is that third power or cubed?
Cubed.
It's actually read as cubed. That's in your textbook here. And you'll hear me say third power, and I mean, oh, cubed.
So technically, that is x to x squared.
Right, 4x squared. Uh-huh. Again, your unknowns or your invisible math. If you have 12x, then really that's the same as saying 12x to the first power. It's the same thing, right? Because if you multiply one, that x is 2 and you multiply, yeah, it's just 1 to the 1 power. And that's just a known that you know. So, all right, flip over to the next page. We're getting there. We don't have much more time, but we're getting there.
What are we getting
We're going on page 4.
to? I know, but like, are we getting to where we figure out what the x is?
Not yet. That's coming. Right now we're doing basics, okay? All right, so if you have an expression of 5 and a base is 5 and an exponent is 1, it's really read as 5 to the first power. Okay? In other words, it really just means 5. That may be confusing, but it's in the table on page 4, and you'll see it at the top. Just go along with me. What if you have 5 squared? If you have 5 squared, that really means it's 5 times 5, which equals 25. You're multiplying those together.
Yeah, I know. I'm thinking
If you have 5 cubed, you've got 5 times 5 times 5, which is 5 times 5 times 25. 25 times 5 is what? 125.
what the? Totally off.
What if you have 5 to the 4th power?
5 times 5
5 times 5 times 5 times 5.
Which is 625. Yes, 625. Okay? Now, if you have AB to the 3rd power, I'm going to come back to that. I want to stay with basics a little more. Go down to 1.1b, and the bell's going to ring, and I'm going to run out of time. If you have x to the 4th power, what is your base?
X.
X. What's your exponent?
4.
What is it? How is it read?
X.
Which means x times x times x times x. This is the important part I want to make sure everybody understands. If you have 6y to the 3rd power, how is that written? Or what's the base?
6 and y.
6 and y. You have 2 bases. What are your exponents?
1 and 3.
1 and 3. Why do you have an exponent of 1?
Because 6 to the first power.
Because it's a known, right? Well, how is it read?
6y cubed.
6y cubed. What does it mean?
6
6 times y times y times y. Let's look at C. You have y plus 2 cubed. What is your base?
Y plus 2.
Right, that's what's inside the parentheses.
Square, right?
Square. You're right, thank you.
Yeah.
So what is the exponent? 2. Now, this is important. How is it read?
The quantity y plus 2 squared.
Does everybody see that? I want to hear everybody. The quantity of y plus 2 squared, which also means y plus 2, y times 2 plus y times 2. There's a y plus 2 times, in the middle, times y plus 2.
So
You
if
see
it's
it.
in parentheses, we say the quantity for it.
Mhm, that's right. All right, everybody look at D. 9w. What is your base? 9w. What is your exponent?
1.
Because you have invisible exponents, right? It's read as 9w, and the meaning is really 9w. Okay? All right, the bell's getting ready to ring.